Here's problem number 82 from the Chapter 3 review. We have a function and we're going to find some various derivatives. Let's do part A. What is the derivative of this function? Well, the derivative of y with respect to x, of course, is dy dx. The derivative of this, I'm going to pull the 1/2 out and then just look at what's the derivative of this inside. This e to the x, well, the derivative of e to the x is e to the x, and the derivative of e to the negative x is e to the negative x plus a chain rule of -1. That equals 1/2 e to the negative x minus e to the negative x, or e to the x minus e to the negative x over 2. In part B, we're going to take the second derivative of this. We'll take the derivative of, with respect to x, of dy dx. And of course, we'll take the derivative with respect to x of e to the x minus e to the negative x over 2. Again, on this one, we'll pull the 1/2 constant out and look at the derivative of this. The derivative of e to the x is e to the x. Minus, repeat, and then we have a chain rule, and it ends up that this ends up being 1/2 e to the x, and then that negative and that negative create a plus, and we end up exactly where we started, which was e to the x plus e to the negative x over 2. In part C, we want to find the line tangent at x equal 1. Well, we'll need to find what is the value of y when x is 1, and that is e to the 1 plus e to the negative 1 over 2. And then the other thing is we're going to want to know what dy dx is when x is 1. That's going to be e to the 1 minus e to the negative 1 over 2. And then putting together to find the tangent line, we find that we end up getting y is equal to the slope, which is e minus e to the negative 1 over 2 times x minus 1 plus e to the 1 plus e to the negative 1 over 2. If we try to clean that up a little bit, we end up with e minus e to the negative 1 over 2 x minus e to the minus e to the negative 1 over 2 plus e to the negative 1 over 2. Cleaning this up a little bit, we have a negative e to e over 2 and a positive e over 2. Those two cancel, and then that's this negative that end up combining, and we get 2 of these e to the negative 1s. So we end up with e minus e to the negative 1 over 2 times x plus e to the negative 1 being our tangent line slope. If we want to find the normal in part D, the normal is going to be the same, except it's going to be 2 over e minus e to the negative x. Of course, it's also negative x minus 1 plus the value of this, that's not an x there, sorry, that's a negative 1, plus e to the negative 1 all over 2, or 2 times e minus e to the negative 1 x plus 2 over e minus e to the negative 1 plus e plus e to the negative 1 all over 2. And we'll leave it at that. Are there any points where the tangent line is horizontal? Well, then the question is, are there any points where the first derivative, e to the x minus e to the negative x over 2 is equal to 0? Which is there any place where e to the x, if we multiply both sides by 2, we get e to the x minus e to the negative x equals 0. Or is there any place where e to the x is equal to e to the negative x? Well, if we divide, or if we take the natural log of both sides of this, we've got essentially e is where x is equal to negative x, and there's only one place where x is equal to negative x, and that's where x is equal to 0. So x is equal to 0 is the only place where this particular curve has a horizontal tangent.